Andy here, and welcome back to another episode of Clef Notes Music Videos. This is the first video in a multi-part series that will cover how I designed and built my own personal virtual pipe organ, or digital organ. Now, this project was in completion for the requirements of the Purdue University Fort Wayne Honors Program. I'm a 2026 graduate of Purdue University Fort Wayne. I received a Bachelor of Science in Music, a particular focus on pipe organ, and a minor in journalism. I was also a part of the PFW Honors Program, and one of the last things you do in the Honors Program prior to graduation is a final honors project or capstone project. My capstone project was to design and build a virtual pipe organ. It took several years to design and build this, particularly the version that I was looking to do required some somewhat specialized software and approach. But in the end, we did accomplish that. It's been built, and I want to share that knowledge with all of you folks out there. Whether it's a digital continuo organ or something that looks a lot more like a traditional church organ or church pipe organ, the design steps are the same. A digital pipe organ is a digital pipe organ, and the core components of such an instrument remains the same, whether you have 1, 2, 3, or more keyboards and foot pedals. This first video is going to be a rough overview of what this instrument is, where I got some of my inspiration, some of the components of a virtual pipe organ, and then video 2 will actually get into the components I chose and how I built the instrument that you see here on your screen there on the left. So without further ado, thank you so much for stopping by, and let's get started. So the first topic we have to address is, what is a virtual pipe organ, or VPO? Basically, it's a computer that's been connected to some kind of keyboard, not a typing keyboard, more like a piano keyboard. And that creates a virtual pipe organ. Now, you may not have heard the term VPO. You may have heard other terms like digital pipe organ or digital organ. These are all the same terms. It's the same thing. It's some kind of computer running software connected to some kind of keyboard that a musician plays, and it sounds like a pipe organ. So, pretty simple concept. That's all it is. Now, for a virtual pipe organ, or VPO as I'm going to refer to it throughout this video, there are really 5 major components. First component for a VPO is the software. And what this software is this is the actual sounds that you want to produce, the sounds that simulate that of a pipe organ. Frequently, those sounds are audio samples. So some audio engineer has gone into the field, into a church or some other venue, and has taken recordings of real pipe organ pipes and how they sound in that room. Those recordings are then put into a piece of software, packaged up into some kind of program, which you can then download and then play, if you will. There are other types of software out there that act more like synthesizers. Those are just approximating the sound of a pipe organ, and some of the synthesizers have actually really improved. But the most popular method nowadays is what's called a sampler or sampled instrument. And that's exactly what I described. These are actual recordings of real pipe organs that have been put into a piece of software that you can then download and play. So that's the first element that you need. The second element is a computer. That's to run the particular kind of software. We'll get into a little more about computers in another slide. 3, you need some kind of keyboard at minimum. So that's going to be something that you can plug into the computer and actually play music. So that means that the keyboard actually has to be what's called MIDI capable. MIDI, which is M-I-D-I, is a standard within the musical world. It's a electronic standard, if you will, that allows keyboards to talk to computers and vice versa, letting you play music from the keyboard through the computer. You also could add foot pedals. This is a whole other ball game from what I was dealing with. Really, it comes down to what your use case is for this VPO. If you want an actual practice instrument, something that you could practice on and then go to church and play on it, or what have you, then you will need a set of foot pedals. And again, those foot pedals will also need to be MIDI capable. Fourth component are speakers and or audio equipment. So once you are actually playing this music, you've got the VPO software downloaded to the computer, you've got your MIDI capable keyboard plugged into the computer, you actually want to hear something. And that's only going to be done if you have some kind of speakers, either those built into the computer or more likely some external audio speakers. To connect to those speakers, you frequently have to use some kind of audio interface. And that's why I say speakers/audio equipment, because you can have a little bit of an audio chain. You have an audio interface, you can have audio interface and then a preamplifier and then speakers. You could have already amplified speakers. Whatever it is, that's going to be one segment of your VPO design. Last but not least, you're going to need some kind of cabinet, and that is to contain all of these components. Now, you can have everything just sitting on a table. That's perfectly fine. But most likely, you're going to want to corral all of this stuff into one basic box, similar to what you see with the professional organs. So that cabinet could be anything. Usually it's going to be made of wood. It's whatever you can get your hands on that will fit the budget and will fit what it is that you're trying to do. So every single VPO that you see today, whether it's those in churches, practice rooms, what have you, these 5 components are the essentials of what a VPO contains. And regardless of how many manuals you have, whether or not you have a set of foot pedals, you're going to need these components in order to accomplish a VPO build. Let's take a look at a very simple block diagram for a VPO. And this kind of shows you the pathway that's taken from when your fingers touch the keyboard to when you hear something. So that keyboard, is connected to that computer, which is running software. The computer/software isn't connected to an audio system, and you hear music. So in reality, it's a very simple chain. The problem is getting all the different pieces to talk to one another, particularly getting the software talking to the computer, the keyboard talking to the computer, and the computer talking to the audio system. And this is probably the most difficult part of a VPO build, is getting all the components to work. The concept is not difficult. It's finding the components and getting those components to play nicely with one another. That's the real challenge. Alrighty, let's take a quick look at some of the most popular, or at least best documented VPO software is currently available as of July 2026. Some of these are going to be samplers that have real recorded pipe organ sounds. Others are more synthesized style software that are trying to approximate pipe organ sounds. So there's a variety here. There's probably others out there. Feel free to add those in the comments below. Number 1 is, of course, Hauptwerk. This is probably the most popular way of doing and building a VPO in 2026. It is paid for. You will have to pay for a license or a monthly subscription fee. That's also an option. I think they do offer a free trial, so you can try it out, see what you think about it. That license is going to cost you a couple $100 up to $600, at least at this time of recording. The sample sets you can download, there's a tremendous variety of sample sets, so some really awesome work and a lot of hours that the Hauptwerk team has put into that project. But again, some of those sample sets, many of those sample sets will be paid for. So you will add on the cost of those sample sets on top of everything else, paying for the actual license. That being said, there's a very active community of folks on Facebook and around the internet using Hauptwerk. They seem to really enjoy it. So this is definitely an option out there. Option 2, this is kind of the main alternative to Hauptwerk if you want to get in to the VPO scene without having to shell out a couple $100. GrandOrgue is free. It's a free download. There's developers contributing to this project. It's a community-driven project. So that's nice to see something of this caliber coming out for free for use of by us organists. So really great project. You'll download GrandOrgue from GitHub. So if you ever heard of that website, so it's not like an established website like Hauptwerk. This is more of a repository style website, GitHub. And it's a great website. does well. I've not really used it much, but for GrandOrgue, I did use it to download GrandOrgue onto multiple systems. GrandOrgue is available on multiple different operating systems. I tested out personally on Windows and Linux, including the Raspberry Pi version of Linux. Worked well. I don't really have many complaints about it. It does have its shortcomings. I don't think it's as stable as could be desired, but that could just simply be user error on my part, or even some issues with electronics. GrandOrgue. This is an interesting piece of software. I haven't used it, and what I can find online has very limited documentation. From my research, I see a few videos about it on YouTube, but it's very similar to GrandOrgue. It's also free, so that's a really, really big plus in my book. Like GrandOrgue, it seems to be you can also download sample sets for it. GrandOrgue is a sample set base, just like Hauptwerk. GrandOrgue looks to be sort of a hybrid between sample sets and synthesis. Don't quote me on that. You need to do some more research, download it, try it out, and see. But it's another option. It's available, and it seems to be something. It at least gives another option, another flavor for everyone to use it. You also have to look and see what the file size is like. It could be that GrandOrgue or GrandOrgue is a small file size. It requires less robust components and power for the computer to run. So do check that out. Aeolus, hopefully I'm pronouncing that correctly. This is a synthesizer-based VPO software. Runs on ridiculously low power computers, devices. So again, I haven't tried it, but I've seen some videos and postings about it, and people seem to really enjoy what it's doing. And the fact is, synthesizers have come a long way in development to the point that they're starting to sound pretty much like real pipe organs at times. So give it a try, see what you think about it. Again, that's also free, just like GrandOrgue and GrandOrgue. Organ Tech. This is an interesting piece of software. I had this recommended to me by an early music professional musician, and he really seemed to think this was a good option. I've done some research on it. I couldn't afford it for my project, so that's why I didn't purchase it. But this company that makes Organ Tech also makes Piano Tech, and I believe its Piano Tech has a harpsichord sound. So you can have harpsichord, piano, and organ if you buy Piano Tech and Organ Tech. That cost is around $200 for Organ Tech, and again, it's a synthesized based instrument, not a sampler. So that's a quick overview. I'm sure there's other pieces of software out there, or that will be coming out there. I'm sure there's changes that will happen to all these sample sets and pieces of software. Even GrandOrgue, you can purchase sample sets for it, but there's so many free sample sets available that, to me, it doesn't really make much sense to buy it, at least initially. So give any of these pieces of software a try, see what you think, and hopefully there will be greater development over time and greater documentation, letting us give us another option in the organ world. So looking at current operating systems, this is the stuff on your computer that is going to have to talk to whatever VPO software you download. So if you download GrandOrgue onto your computer, you need to make sure that if you're running Mac OS, that Mac OS will run GrandOrgue. Same thing with Hauptwerk. Same thing with GrandOrgue. You have to make sure that the computer operating system talks to the VPO software and vice versa. If it doesn't talk to each other, things are not going to run, or at least not run correctly. And if you're depending on this instrument for practice or religious services or performance, you need this to be working and working well. This is really where homemade virtual pipe organs fall down. And that's because what we are trying to do as do-it-yourself builders is never going to equate what someone like Rogers or Allen organ can do with their instruments. Rogers and Allen are using dedicated pieces of software that do only one thing, and that is play the sounds of a pipe organ. What we're trying to do with a DIY VPO is download a comprehensive operating system onto a computer, and then we're just using all of that potential to do one task. So there's stuff in, like, for example, Windows that we never need for a VPO. We don't need a text editor. We don't need a web browser. We don't need all the other things that come with Windows. Same thing goes with Mac. Linux is better, although you could get into a disagreement over whether or not Linux is a full operating system or if it's more kernel, if you will, of an operating system. But again, there's stuff here that we just don't need. And that means that there's waste, if you will, that we're not dedicating everything that we can to just doing one thing, because these operating systems were not meant to just run pipe organs. They were meant for home use, university use, business use. So all that being said, don't expect that you're going to get the same level of reliability and repeatability from running something like Windows 11 and GrandOrgue. It's just not going to happen. The only way that is going to be achieved is if we eventually get to a point where we have dedicated pieces of software like Rogers, like Allen use, working on electronics that only run pipe organs and virtual pipe organ software. Now, in my use case, I only tested GrandOrgue. I used it on Windows 10, Windows 11 on a laptop, worked fine. I used a Windows 11 handheld gaming PC, the Lenovo Legion Go, worked fine. I used it on Linux Ubuntu with a 6 to 10-year-old HP laptop, worked fine. I used it on a Raspberry Pi 5, which is I used the 16 gigabit version. It worked with a particular operating system called Pipean. We'll get into that a little bit later. So again, GrandOrgue works on almost anything. Double check, do the due diligence, see if the software of choice is going to work on your computer's operating system. Because that could be a nasty surprise if you have to buy a whole new computer just for this. Let's pivot to actually what it was I built. I've talked a lot about VPO organs, and I mentioned that this is a continuo organ that I built. In fact, the picture you're seeing here is the completed product of what it was that I built. And there are a few differences between what I built, a continuo organ, and a regular pipe organ. So let's ignore the whole virtual pipe organ, digital organ idea for a minute and focus on the key differences between what you might see in a church, a regular pipe organ, and a continuo organ. So a continuo organ generally has just one manual, basically just a keyboard. Typically no foot pedals, so not like what you usually see organists playing and what we're trained in college. And it's used for continuo playing or Baroque era music. This is the most common usage. What this means is, as a continuo player, you're probably playing music from roughly the 16th to 18th centuries, a lot of the 17th century. And what it amounts to is you are realizing a figured bass. So you're playing chords, you're filling in chords and harmonies for an ensemble or at least multiple musicians. So for example, you could have a singer, a violinist, and a continuo organ player. The singer or the violinist will have the melody. The continuo organ player will be playing that harmony and filling out the structure underneath that singer or that violinist. So it's a really fun way of producing music. This was very common back in the Baroque era. So, roughly 1650, 1750, right about in that area. It's not so much used today. The closest approximate we really have today to what they were doing back then is jazz musicians. Maybe also you could consider Nashville numbering system as well. This idea of having something written that indicates that harmony, but not the actual full music written out for you, like what we're used to in a lot of classically trained musicians today. So let's take a look at what continuo organists or continuo players will actually see, because it's not just for organists. Also, if you play the viol da gamba, harpsichord, lute, a lot of those musicians playing the continuo line are realizing this figured bass. They're creating harmony from what is they're seeing here in the music. So this is a quick example of what continuo playing looks like. Actually, this is from a work that I did play with a PFW early music ensemble. This is a really, really fun way of producing music in my mind. I love this style of music as it is, but then learning how to read this kind of notation is also very, very interesting. So this again is from a piece that we performed with the PFW Early Music Ensemble. And what you see here is 3 staves. You have a violin playing that upper part. You're going to have some kind of perhaps singer or what have you doing that middle part. And then you have the basso continuo line. Now you'll notice in the basso continuo line, there's just one line of music. But if you're someone trained to play piano or another keyboard instrument, usually you have at least 2 lines. Something for the right hand, something for the left hand, and away you go. Not so in this kind of music. In this case, what you see here is a single line of music, generally written in bass clef, and you have notes and numbers. The numbers are an indication of what the harmonies are built above that note. So for example, in that first red arrow that you see, you'll see you go from a C natural down to a G natural, and you'll notice there is this 6-5. And what this is this kind of a suspension. So what we're going to have is you're going to have the note a sixth above that G natural, which in this case is an E natural, stepping down to a D natural, 6 to 5. You see this also here with the second red arrow at the end of measure 3. You have an E natural with a 6 written above it. Again, this is going to mean that you're going to be playing a note a sixth above the written note. Now you also play the written notes. You're not ignoring those. It's just this is indicating the harmony that's happening above it. For this particular case, this is basically a first inversion C major triad. I haven't done the Roman numeral analysis to tell you exactly how it's being used in this context, but you see that 6 there indicating you do have the C natural above it. Move to that next measure, you see a 7-6. Here's a 7-6 suspension. You move on to this B natural here in measure 5. You see again a 7-6 suspension, but now you've got a slash through the 6. What that slash means is you're going to raise the 6 a half step up. So in this case, we're going from B, so B, C, D, E, F, G would be a 6 above. A would be a 7th above, so you're going from an A down to a G sharp. So it's all of this kind of stuff happening throughout the piece. So again, this is a really cool way of writing music, of playing music. It used to be very common, and now you're just going to see this kind of performance with early music ensembles and enthusiasts. But it's really a wonderful way of understanding theory. I remember I told this to my mentor at PFW and my mentor for this project, as well as for much of my music career at the university, which is if we studied music in this way and performed music written in this manner with this figured bass, as it's called, it would make theory classes so much easier to understand. Because instead of just textbook examples, some homework, you hear it, you see it, you perform it, you sort of live that written notation, that continual playing. And it brings all of this idea of harmony and how this works in theory to life. So I'll get off my soapbox here. This is a quick example of how continual playing looks like, how it's done. I am only very much a beginner in all of this. I spent about 1.5 to 2 years learning how to read this and performing it. Again, that's thanks to my mentor, Dr. John Romey, who's now at Indiana University's School of Music there. One of the last important elements you need to consider when designing and building a virtual pipe organ is, are you going to build a case? If this is an instrument you want to use for, historically informed performance practice, then you will want a case, and you want to design one that looks like something similar to a continuo organ from the 17th century. If this is something for your church or another performance venue, then the case can be pretty much anything you want, however you want to design it and build it. If this is for your home, you may not even need a case. You could just put everything on a desk or a table or something of that nature. The case is one of the physically challenging elements to this project because you're going to do a lot of woodworking. So bear that in mind. That's something that you are going to need to take in consideration. You'll need to add that for the cost of the instrument, as well as, are you physically capable of lifting all those pieces of wood, bolting everything together? Sometimes you're going to have to be crawling underneath the case to work on something. You need to be flipping the case over on its side or its end. So there's a physical element to this on how you are designing and building it. So bear that in mind. It's just another element, another part of the challenge, but it's well worth doing. Alrighty, so last thing that we need to cover in this video before getting to part 2 is, why did I decide to do this and spend years of my life designing and building a continuo organ? Really, I think you could attribute it to 3 separate elements. One is divine. I think that God had a reason for me studying and learning at PFW at the time I did. And I think that without his encouragement and guidance, this would not have been possible. As simply as I can put it, that's my personal viewpoint. So that would be the first element, is I think there was some divine leading going on in there, and why I decided to do this at that time. Secondly, it was a case of, practical use case. As a music and outside field major at PFW, I specialized in pipe organ. That was my major instrument. I had secondary instruments of piano, and then, as it turned out, harpsichord. Got to study with some wonderful professors there, Professor Irene Ator, Dr. Daniel Schwant, Dr. Hamilton Tuscarolo, and got to learn all this kind of music. When I ran into Dr. John Romey in his music history class, I discovered a great love of early music. I'd already enjoyed the Baroque era, but I would trace it back to studying Dr. Romey, where I finally had the opportunity to study early music from a professional level. And Dr. Romey has taught early music. He plays the viola da gamba. He's researched this, so he was a wonderful resource and a great mentor. At PFW, we don't have an actual pipe organ. We've got a digital organ. It's a 2001 era Allen Digital. That came in about my senior year in college. Before that, we had a 1974 Allen Digital. But we did have 2 harpsichords, so I learned how to realize figured bass and play continuo lines on harpsichord. Dr. Romey taught me a variety of temperaments. I learned how to tune a 1/6 comma, Rameau. We had a few other temperaments in there. But we didn't have a dedicated digital continuo organ. And if you're someone that studied early music, you know that the sustaining tone of a pipe organ adds something really cool to the tonal timbre, the tonal color of a piece of music. So we didn't have the money for a continuo organ. Those things are usually tens of thousands of dollars. There is one for sale that's digital in the Netherlands. It's made by the company Johannes, called the Johannes 1. It's about $3,000, not counting the expense you'll need to purchase a case, external speakers, and all that. So that wasn't in the cards for the department. And as someone that specialized in this early music area, I got curious to know, is it possible to build something for a lot cheaper? And as it turns out, it is. It definitely is. And that brings me to the third source of inspiration, which was this video by English organist Richard McVeigh. He's from the UK. Runs the YouTube channel Beauty and Sound. Do check it out. Wonderful channel. He gives a lot of great information about Hauptwerk and how he uses it. And he designed and built his own Hauptwerk chamber organ, like what you see here on the screen. Now, this is basically a continuo organ. It also goes under other names, chamber organs, etc. But Mr. McVeigh designed and built this by himself. I think the only thing he actually had someone else do was the keyboard. He bought a designed MIDI keyboard for this. But seeing this video was the inspiration for not only my project, but my design. Because I knew I needed a final honors project at PFW, because I was an honors student, and in order to graduate with honors for the honors program, you need to do a final honors project. So I thought, let's combine my love of electronics, of music, my pipe organ training, and design an instrument that can meet a need for continuo organs that are low cost, and also lay the foundation for people who may want to build their own virtual pipe organs as well, because it's the same root parts needed for both types of organ. So that's what started this entire process. There's a lot of prayer, career necessity, or at least interest in this video by Richard McVeigh. So thanks so much for watching. In part 2, we'll go through the entire project. I hope you find something useful. Again, if you have any comments or questions, please post that in the comments below, and I'll try my best to answer those. Thanks so much for watching. Take care. God bless.